Hey, hi, hello guys, welcome back to Code with Nani channel. So today we're going to discuss the lead code problem of the day, maximum absolute sum of any subarray. So you are given integer array nums. The absolute sum of a subarray is from nums of L plus 1 and so on, R minus 1 until R is absolute sum of nums of L to R. So suppose, what this problem statement says is, suppose you have an array minus 2 minus 3 minus 4 and 5. Suppose we are taking this subarray, which is, so what will be the absolute subarray sum? So add minus 2 minus 3 and minus 4, what will be the sum? Minus 9. So what is the absolute subarray sum? Absolute of minus 9. So when you do absolute, which means we only take the positive values, which is 9. So for this subarray, the absolute sum of a subarray is 9. So, or in other case, if you have only positive integers, then we directly return the positive integers. So that's what he mean. And so we need to return the maximum absolute sum of any possible subarray of some num psi. So let's take an example. We have a 1 minus 3 2 3 minus 4. So if you take the case, so maximum subarray sum, absolute subarray sum is these two elements. So if we take any other case, so you will be getting a value which is less than 5. Suppose if you take this subarray, what will be the value? 3 0. And if you take this only to these two subarray, which is minus 1. So if you take absolute, it will still be a 1, but it doesn't increment more than 5. So this is the best subarray that gives the maximum result, which is 5. So that what is mean. Suppose if you take another case, 2 5 1 minus 4 3 2. So whatever be the subarray sum, so if you take this subarray, that gives us the maximum result, because if you add the negative values to the positive number, the sum will be decreasing. So that's why we don't take this and this. So if you take this subarray sum, that is minus 8, so we are taking an absolute number, which is 8. So this will be the high maximum subarray, absolute subarray sum. So that's his answer. So so if you carefully observe the problem statement, what is it saying? Maximum. So just for now, just don't consider this absolute. What is this? Maximum sum of any subarray. So for the brute force solution, what you can do is you can iterate through the sums and you can generate all the subarray sums, and you can return the maximum solution out of it. So which takes off n square, because to iterate all the subarrays we need n square solution. So as constraints are 10 power 5, it gives you a TLE, so we need to find a solution which is order of n log n or less than O of n log n. So if you carefully observe, it's a maximum. If you just don't consider this absolute thing, so it will be the same solution as maximum sum of any subarray. So what you can do is you can use cadence algorithm, which is to get the maximum subarray sum. Okay, so as it only gives you the it only gives you the positive sum. So what you can do is you can use a cadence algorithm, which is like iterating over the elements, and sum plus equal to array of I, answer is equal to max of answer comma sum. If sum is less than 0, so what we can do is we can start from any positive integer that leads to a maximum sum, or else it will be the highest negative sum. Okay, sum is equal to 0. This is a piece of code that for the cadence algorithm. What you can do is you can generate the maxi, which is cadence of nums. So this gives a positive subarray sum. But cadence algorithm will only works on the positive integer. So if you want to get the like uh, when it is an absolute, which means there is a contribution of the positive subarray sum, or it can be a negative subarray sum, right? So maxi can get you the positive subarray sum. So if you want to get a negative subarray sum, what you can do is you can multiply just iterate over the array and multiply all the numbers with a -1. So what will be happen, so you are interchanging the signature, so that if you do again the Kedis which is mini, so if you do the Kedin's algorithm again, which means it will give you the result based on the positive integer, but what we are doing is we are alternating the sign, so which means we will get a mini sum, so which is we'll get a mini sum and just return what is the max of maxi or mini. So you can use the same write a cadence algorithm function. So without positive integer, you'll get a maxi, and just multiply each and every integer with a -1. So you'll get a mini subarray sum as well, and just return the max out of it. So in that way, you can solve this problem in the order of n time with a space amplitude of O of 1, because we are not using any additional data structure. Suppose if you want to optimize still more without using the cadence algorithm, what you can do is, so you can use the concept of prefix sum. So if you plot the graph between the prefix sum, suppose we have a prefix sum, suppose there can be a, like, let's just start from the 0. If the prefix sum is 2, and if the prefix sum is 5, and if the prefix sum, like if you are adding the negative integers, then the prefix sum will be reduced, right? 1 and -4, -3, in this way. Suppose if you plot the graph, this is the graph. So what you can do is just have a, this is the highest element and this is the lowest element, right? So this will be the absolute sum. So how do you, so you will ask me how Nani, how we can get to this situation, like how the gap between the maximum and minimum will be the absolute sum. Suppose, so how, if you want to find a prefix, if you want to find a prefix sum over a certain range, what the formula that you are using? We are using prefix of r, which is the rightmost index, minus prefix of l plus 1, sorry, l minus 1 will be our sum. So if you want this sum to be as far as the maximum, then what we need to do, we need to maintain this particular thing should be a max, so that if you subtract, this should be as far as the minimum, so that when you do subtraction, then the sum that we get will be the maximum, right? So in order to be prefix of r should be maximum, so the point of the element should be at the peak of the graph. So in order to be this minimum, it should be the as low as the lowest point. So in that way, so if you subtract both the elements, you will get the absolute summation. So did you get my intuition right? So how do we implement this? So just what you need to do is you'll just iterate through the elements, and what we maintain a prefix sum. Okay, we'll maintain a prefix sum. So we'll just compare it with the maxi. Maxi means which holds the maximum integer, that holds a maximum of maxi comma this particular sum. If the sum increases into a positive integer, then maxi will be updated. And what the mini holds, minimum of mini comma this sum. So if it goes as beyond as negative values, then mini will be updated. And in the end, what we are doing, we're just returning the gap between the maximum and the minimum. So in the end, just return maxi comma maxi minus mini. So that will give you the desired result. So let's just walk you through the course, so we'll get clear picture about the solution. So let's just jump into the Leetcode solution. So yeah, as you can see, what I'm doing is I'm just declaring a n, which is the size of an vector. So which is ps is the prefix sum. So to maintain a prefix sum of the elements, I'm just declaring the variable. And maxi holds the maximum value of the peak element, mini holds the minimum of the bottom element. So I'm just iterating to the array, which I'm returning to the vector, and just maintaining a prefix sum. If the prefix sum is positive and it is more than the previous max element, then maxi will be updated, and or else mini, if it is a minimum element, mini will be updated. And in the end, we need to retrieve the gap between the maxi and mini. So that for that case, I'm just subtracting with the maxi with the mini. So I'll just run the code. Just submit the code. Hola, it's submitted, and that's it for the today video, guys. If you liked my explanation, do like the video, subscribe to my channel, and hit that bell icon so you never miss any notification from my channel. And that's it for today video, guys. Thank you, tata, bye bye. See you tomorrow with a new video.